Hello. Now, the question that we consider today comes from Cambridge International Advanced Subsidiary and Advanced Level paper. And the paper is paper 6, Probability and Statistics 1, taken October-November 2019. The code is 9709/61. The question of interest is question 4. And question 4 reads, this is a continuation of our series of considering discrete random variables. That is a topic in probability and statistics 1, that is paper 6. So the question that we consider reads, in a probability distribution, the random variable x takes the values -1, 0, 1, 2, 4. The probability distribution table for x is as follows. X is -1 with a probability a quarter, 0 with probability p, up to 4 with probability 4p. Find the value of p, that is 2 marks. Then Roman 2, find expected value of x and var of x, that is expected value of x and variance of x. Expected value of x is like the mean or the average, and that gives you 3 marks. Roman 3, given that x is greater than 0, find the probability that x is equal to 2. That is 2 marks. So let's consider the solution. Well, the question as seen, we need to, in a probability distribution, the random variable x, we are told takes the values. So x and probability that x is equal to x. Now, this one again is an example of a discrete random variable. Discrete random variable. So we see that x can take the value -1, it can take the value 0, it can take the value 1, it can take the value 2, and it can take the value 4. Those are the possible values that x can take. But it can take x with the probability of a quarter, or 0 with probability of p, or 1 with probability of p. So it takes the value 0 or 1 with the same probability. And it takes 2 with probability 3 over 8. And it takes 4 with probability 4p. Now, this combination of 0 and 1 having the same probability is necessary in now in discrete mathematics. In that aspect, that's fair enough, because both digits, if used in coding, have equal opportunity, if that were the case. Now, find the value of p, 2 marks. The value of p, 2 marks. Just first thing we do is to find the value of p, and that's how many marks? 2 marks. We should remember that total probability should add up to 1. That's the first condition. Total probability is supposed to add up to 1. And so it means that I can add all this and equate to 1, then make p the subject to get the solution. So I have, probably, let me say, a quarter. This is p plus p, that is 2p, plus 4p, that is 6p. So I would say summation of p should give me 1. Therefore, 6p plus, that is this 2p plus 4p, 6p plus a quarter plus 3 over 8. A quarter plus 3 over 8 should give me 1. But what is this? 8 is the LCM, and that is 3 plus 2. So the whole of that is 5 over 8. So I have 6p plus 5 over 8 is equal to 1, implying that 6p is equal to 3 over 8. And so what is p? Therefore, p will be, because it is 48p is equals to 3. So p will be 3 over 48, which is 1 over 16. P is 1 over 16. That is the first. So that's Roman 1. P is 1 over 16. Roman 1. Then we move to Roman 2. No, this is Roman 1. Then Roman 2. Roman 2. Find expected value of x and variance of x. So expected value of x in this case will be x dot probability that x takes up a particular value. There is summation, and that is what makes it so. There is a summation. So here it says equal to summation of x dot probability that x is equal to x. Takes that value. So I'll then come here, multiply -1 by a quarter. And that gives me -1/4. Plus 0 times p. Of course, we already had p to be 1 over 16. So here I can put 1 over 16. Here 1 over 16. And then here 4 over 16, that is 1 over 4. This should be a quarter. So 0 times 1 over 16 is just 0. Plus 1 times 1 over 16 is 1 over 16. Plus 2 times 3 over 8, that is 6 over 8. Plus 4 by a quarter, which is 1. So on adding all this is like saying same LCM. LCM is 16. LCM is 16, which comes here twice. So that's 12 plus 1 plus 1. Then minus plus minus 4. And everything here plus 1. That should give me, so 12 plus 1, that's 13. 13 minus 4 is 9, so that's 9 over 16. 9 over 16 plus 1, which will be, if LCM is 16, that will be 16 plus 9. So it's 25 over 16. 25 over 16. 25 over 16 is the mean. That's the expected value. So we are also asked to get the variance of x. We are also asked to get the variance of x. So if that is the expected value, then we expect the variance to look like, okay, so it's still Roman 2, the other part. So we say variance of x, var x, is given by expected value of x squared minus expected value of x squared, like that. But expected value is this, 25 over 16. So probably what I need is these ones, expected value of x squared. What I need is the expected value of x squared. So it will be 1. This should then be, okay, I say, but expected value of x squared is given as summation of x squared dot p of x is equal to x, like that. So in effect, this will be, you square this, so it will be minus 1 squared times a quarter plus 0 squared times that, which is just 0. Then 1 squared times 1 over 16, which is just 1 over 16, plus 2 squared, which is 4. dot 3 over 8 plus 16 dot a quarter plus 16 dot a quarter. This gives me, that's just one anyway, so I get a quarter plus 1 over 16 plus 3 over 2 plus 4, which is equal to LCM is 16. So 64, we are 64 plus 24 plus 1 plus 4 plus 4. So 5 plus 24, that's 29. 29 plus 64, 29 plus 64, I get here 3, that's 8, this is 93. So this gives me 93 over 16. Because it is 1 over 4, 1 over 16, and then 12 over, yeah, that is that, plus 16 over 4, yeah, like that. So that gives me, we see it gives me 93 over, let me just add up again, 64 plus 24, 64 plus 24, that's 8, 88. 88 plus 5, that's 93. So here I get 93 over 16. That's what I have. But variance should be expected value of x squared minus that. Therefore, var of x will be 93 over 16 minus 25 over 16 minus 25 over 16. So this, if worked out, if we work this out, if you work it out, that is definitely 93 minus 25. It is 93 minus 25, which will, no, because we square this. You see, this is 25 over 16. We square it. This we should square. We should square this. We should square this. So if we square it, we need to square it. So it's 93 over 16 minus 25 over 16 squared. If you work that out, you should get, use your calculators, you should get 3.37 as the answer. Working that out gives you the variance of 3.37 as the answer that is required. Now, the other part requires us to get, given that x is greater than 0, find the probability that x is equal to 2, and that's 2 marks. So this what we have is that you are required to get, given that x is greater than 0, find the probability that x is equal to 2. So we want probability that x is equal to 2 given that x is greater than 0. Now this is a conditional probability. And in a conditional probability, what happens is that we should then have probability that x is 2. Actually, the general condition should be probability of A given B. Just a minute. So that we see probability of A given B is equal to probability of A and B over probability of B. That's what we have generally, but now I want to apply it here. So that becomes probability, because we are just using that, becomes probability that x is equal to 2 all over probability that x is greater than 0 because it's strictly equal to 2. But then what is the probability that x is equal to 2? Probability that x is equal to 2 is 3 over 8. So here we have 3 over 8 divided by 3 over 8 divided by 3 over 8 divided by probability that x is greater than 0. Probability that x is greater than 0. So that will be probability that x is greater than 0. We'll add this to this to this. So 1 over 16, let's just add somewhere. Is greater than 0. So we start from here. 1 over 16 plus 3 over 8 plus 1 over 4. LCM is 16. So that's 4 plus 6 plus 1. So this is 11 over 16. We get here 11 over 16 as the probability that x, just a minute, as the probability that x is greater than 0 is 11 over 16. 11 over 16, that. So divide this by 11 over 16. And that then implies that 3 over 8 times 16 over 11 is 3 over 18 now times 16 over 11. So this is 1, this is 2. So we get 6 over 11 as the probability. 6 over 11 as the probability. And that marks the end of the question. And so that's all that you are needed to do. Up to there, meet you in my next video.